So today in this STAAD Pro, we will see complete concrete design. Like we will start with beam, column and also slab design. So I am just going to draw our structure. So for example, for the basement, I'm just going to consider as 4 meter height, and then I'm just going to consider 7 meter. So this I'm just going to translational repeat. So in Z direction, so totally 3 number of steps with 5 meter spacing. So link steps, open base, click OK. So like this we have. Now the same I'm just going to repeat to the top also. So in Y direction, I'm just going for only one. So otherwise we can just take only these portions. We can just go for translational repeat, number of steps 1 and then 3. So in Y direction, so link steps and then click OK. So again I just want so these two and also this one and also this one. So translational repeat in Y direction. So I'm just going for 3 meter link steps and then click OK. So this we can able to see in 3D rendered view by clicking this icon, or we can just go for right click also. So now I'm just going for support. So support, create and then add fixed support. So we can able to confirm an isometric view. Immediately we need to go for property and then define. So rectangle. So I'm just going for 9 inches plus 9 inches. So I'm just going for assign to view. Now, so I'm just going to select these kind of beams over here, or you can just go to front view and then you can able to control, you can able to hold control and you can select like this only these particular beams, and we can just go for fill floor grid with plates. So it will create you the plates automatically. Now we can just go for thickness for the plate. So this is we are going to consider as a slab. So 0.12 or 1.5 we can take. So we will consider 0.12 and then assign to view and just now we can just go for 3D rendered view. See now our structure looks like this. So now we can just go for loads and definitions. First we will go for dead load, and then we also go for live load, and we can just go for self weight for dead load. So assign to view and then live load. I'm just going for member load first. In that member load we are going to consider uniform force and then minus 19 kilonewton per meter. I'm just going to consider in global Y minus, so it will act downwards. So it's a kind of brick load. So this we can able to select beam parallel to X. So select beam parallel to X and then select beam parallel to Z. So assign to selected beam. Okay, if you want to reduce the scaling, we can just go here. So symbols and labels, or we can directly go for scaling also. Here we have this icon. So here in distance force we can able to control it. Now again I'm just going for floor load also. So minus 3.5 I'm just going to consider. So take the node cursor and double click here, this is like a 0 4 0, this is like a minimum we need to put, so in y we need to put only 4, and again I'm just considering this is like a 7 7 and 15, 7 7 and then 15. So but in y we also have this range, so we need to put 10 in a y, so as we also have this one, so y we can able to put 10. Now we can just put add, now it will be like this. So you can see in the front view it should be on top, so it's perfect. So if you want to like change some scaling, you can able to do. So like this we have member and floor loads. So now we also can go for load combination, so click here and then go for add, and then define combination, and I'm just going to put a default of 1.5 factor, and I'm just clicking this option over here and then click add. So which means like 1.5 times dead load and also 1.5 times live load. So when you're clicking the loads, it will highlight in blue color. So this is like self weight, and this is like member load, and this is like a floor load, and this is like combination of load. So if you want to edit the combination also, you can click edit and we can able to see that. Now after doing this, we need to go for analysis and print and click all, and you put add. Now we can just go for analyze, run analysis, save. So we don't have any error or warning, that is much better. So we can just go for view output file and done. So we will get a normal result. Now what I'm going to do means like I'm just going to do concrete design for the structure. So for that we need to click concrete design tab over here. This we can able to get only after analysis. So now I'm clicking this option. So it will go to the external plugin where we can able to design our beams, columns and slabs. See, first we need to start with a envelope. You need to go for a new envelope. So you need to select everything. For example, you can select like this and then you can go for new envelope. Now I'm just going to name as RC design and click OK. And where we can able to select the load cases. So better you can take a combination of loads. Otherwise, if you want separate loads, you can remove it and you can able to select. But combination is better. So select this and then click OK. Now based on the loads only, we will design our members. Now you can just click member. So select everything and then we can just go for members, auto form members. So why we are doing this? See, for example, here we have separate beams, but practically it is a single beam. So that's why the numbers, see M8, M8, M8. So it will automatically become one single member. But columns are different and it is like separated, M19, M17 like that. So that's why we are just putting auto form members. So all the horizontal beam will be acting as a continuous beam. See M2, M2, M2. So holding control, I'm just showing you like totally it's a single beam. So that it can able to like take the loads acting on it easily. That's why we are using auto form members. Now we can just go for select and then plates. Now I'm just going to select all the plates over here. So we have 7 plates. Now I'm just going for a slab and then I'm just going for form slab. Now we can able to see whether slabs created or not. I think only one slab created. See in this basement. So again we can just go for plate cursor, select plates, slabs, form slab. So again another slab created. Again select plate, cursor, slabs, form slab. So totally we created 3 slabs. So that we can able to see in slabs where we can able to see the thickness, net area, cross area, and any holes are there or number of plates, everything. And the thickness also we can able to see here. Now I'm just going for a groups and briefs where I'm just going for a beam brief. So we can continue with the BS 8110 British Standard Codes. where we can able to go for top cover, side cover, bottom cover, and aggregate size maximum, concrete strength. So which kind of concrete you want to use? For example, C20, 25, or you can able to specify your user defined something like this is something like similar to M20, M25, M40, that kind of a combination of concrete. So in that case, you can able to specify your user values also here. And also we can just go for divide beam into 12 segments. If you want more also we can able to put here, but by default 12 segments. And main reinforcement. So in main reinforcement, minimum size 8 mm bar, maximum size 40 mm bar. And also like bottom bar criteria, everything. And shear reinforcement, what you want to change. If you want to change anything, you can change here, even the spacing and everything. And then click OK. So we have created beam brief. And also the same, we can also go for column brief. So we need to select column here. This is important. Click OK. Then we will get the column details. So where we can just go for which concrete you want. And the same. So what are the changes you want? You can able to change over here. Column factors. And also member load cases. Here in column, we need to select the load cases also. For example, I'm just going for only one combination, that load case, and then click OK. So we also created column brief. The same way we need to create slab brief. So we need to select slab over here and then click OK. And again, so the information regarding slab, it will come. So I'm just going to consider C20 or 25. And then main reinforcement. So top bar criteria, 2020, bottom bar criteria, everything we have. So here we also go for design fixed bar size, a fixed spacing like that. So I'm just going for a fixed spacing. Then by default it is like 150 mm. Or we can just go for fixed bar size. We will see how the result it will be. And you can select the bar size also. For example, so here only the cover and also the main reinforcement. So 20 mm bar it's fixed. So we will see how the result it will be. Whether it will take 20 mm bar or something less than that. So click OK. So we also have created slab brief. So now we need to go for new design group and we need to go for beam brief. So I'm just going for beams. So click a beam brief and then click OK. So you need to select the beams over here. Add member to design group. Which design group? Beams. And then click OK. So when you're clicking beam, you should get members here. If it's not, then there's a mistake. We can just delete it. So what we can do is like we can directly go like this. Select, control. So right click, new design group. This is much better. Beams. Click OK. See, now we are getting the members. So it should be like this. And then I'm just going for selecting the columns. Hold control, and then you can verify in isometric view. Right click, new design group. So column. So columns. So we need to select column brief. This we should not forget. Again, we can just go for slabs, and we can just go for new design slab. So in that case, we need to select a slab cursor. Select, and using the control, holding control. So totally. So otherwise we can just go like this, hold control. So we can't select all the slabs together, I think. See, only one slab getting selected. So what we can do is like we can just select the slab and then go for right click, new design slab, and then it is like a telling slab design 1 and slab brief for slab 1. Click OK. Again, right click, new design slab, so slab 2 automatically, and then right click, new design slab for slab 3 automatically. Click OK. So after doing all these things, now we can just go for seeing the members, so slab details, groups and briefs, everything we have. Now we need to go for concrete member over here. See, now it is like showing in summary fail everywhere because we didn't design it. So after designing, it will show you the result. Now I'm just clicking design and then all the members selected and I'm just clicking design. See, some members still failed. So some members passed. So failed tension calculation for hogging, design not possible, tension reinforcement could not be designed in span 1. So insufficient tension steel area at 0 meter. So some members like failed. So we can just go for main layout and then shear layout. See, for example, for M2, like we can able to see the reinforcements. So how the main layout, and we can able to see the table and then the bar details, 10 mm bar, and then we can able to see the section here, and that when you are moving also we can able to see how it looks like. That you can able to see here main reinforcement. See here the moment area still required and everything, and also the bottom layer, top layer. So here you have, so 25 mm bar, top we have 10 mm bar, how many numbers, everything. So for beam we can able to refer this. So shear layout, so where we can able to just see how the, see here it is like telling 8 mm bar at 100 mm spacing. So shear table also we can able to see here. So 8 mm bar we can able to go for stirrups, and also the spacing like 9 centimeter, 10 centimeter, 12.5 centimeter like that. Now this is for M2. So M2 what it will be like by member. I'm just going for a click OK. So it is like for beam. So we can also go for columns. So where we can just go for summary, it is not showing anything. We can just go for design and click design. See now some columns fail and some columns passed. So section, dimension and properties are insufficient to carry loading. Because of the load, the 9 inches cross 9 inches is not enough and we need to change the cross section. So these things we can able to do later, but now I'm just going to consider only the members passed and we can just go for reinforcement details. For example, M27. So I'm just going to consider M27 and I'm just going for main layout. See where we can also see the reinforcement details and the moment values and the moment diagrams, everything. Now we can also go for shear layout where we can also see like 24 numbers, 8 mm bar at 125 mm spacing for stirrups. So the result also we can able to refer. So this is for column. And also we are getting drawing that we can also export to DXF. This we also have in beams. So M7 failed, so we can just go for so I think most of the beams failed that we can also make later, but now I'm just going for drawing. See where we can also go for drawings. So you can just click this span, so we can able to split that beam into 3 parts and we can able to print in one paper. Otherwise it will be like a continuous beam. So this is better. You can also just go for click OK by exporting to DXF. This we can also open in AutoCAD or any other DXF viewer. So like this we can also go for saving to DXF formats. Now I'm cancelling. So now we know how to design beams and columns and to see the reinforcement details. Now we will go for a slab. So click concrete slab here. Now we have displacement, nothing, moment, nothing, regions, nothing. Once you click design, and we can also go for design here, then everything it will come. See required spacing. So it is considering only 20 mm bar and 25 mm spacing and then 17 mm spacing for different kilonewtons. This is only for slab design 1. Again slab design 2 I am just going. Here it is showing not available. Once you click design, it will be available. Again for each and every slab we need to do like that. So here for example, result line is there. We can just go for result line, but before that we need to go for displacement. Result line, create. For example, I'm just going to create a line like this. So based on the line, we can able to see the graphs and the values over here. For example, I'm just going for a combination load cases and I'm just going for a maximum top displacement. So this kind of values. So moment values, everything. So here you can just go for drop boundaries. So in region for a regions drop boundary. So you can just go to region. Now select this particular region. So it's already we have one boundary. No need to worry about this. And for about slab design 2, where we can just go for drawing the boundaries. So select like this. So select like this. So we are getting a 3 different regions for one slab. And also for slab 1, draw boundaries. So we can able to see the different cross-sectional areas or surface area and the thickness. So now we can just go for design and everything. Design. So it will come. So we need to do it again. So design. Again for a slab 3, we already have. So for example, slab design 1. See, this is what we have. So 20 mm bar with a minimum spacing of 25 mm, 17 mm like that. So if you change the details in slab brief, then it will consider that. For example, main reinforcement, it is just going to consider only 20, or we can just go for fixed spacing of 150 mm. So click OK. So now I'm just going for concrete slab again. See, now it's changed. So we need to design again. See, now based on fixed spacing, we can able to see the bar size reduced to 8 mm. So 8 mm bar is enough. So that's why like we used to build with 8 mm bar with 150 mm center to center for our slabs. So again, design. See, it is like a 8 mm and also like 10 mm combination at 150 mm spacing. So top 10 mm and also bottom 8 mm and also the different combinations we have for different slabs. So here you can able to see the required steel and then the legends, the moments and also bar sizes, everything from this drop down. So for the slab 3, again I'm just going for design. So 10 mm bar at 150 mm center to center. So like this we can able to design any structure and we can able to study concrete design for beam reinforcements, column reinforcements and also slab reinforcements. So like this. So this we can able to do only in RC Designer, which is like external plugin. So once you complete the structure and analyze the structure, you can able to do RC design. So make use of it. So we will see like different beams and columns and different reinforcement. For example, concrete member, and I'm just going for M8, and I'm just going for main reinforcement, where we can able to see like bottom 2 25 mm bar, top 2 12 mm bar, 4 12 mm bar. So different number of different combination of bars. And for columns, so I'm just going for M22. So main layout. So here we have. So the drawing we can able to see like a 16 mm bar and 8 numbers and also stirrups 8 mm bar. So columns, it is telling 16 mm bar, 8 we need for M22. So drawing, see 1 2 3 4 5 6 7 8. So totally 8 number of 16 mm bar we need to put in our column. Since some of the columns getting failed, we need to go back to the STAAD Pro and we need to change the cross sections and then we can able to come back here. Then we will get reinforcement details for that particular column and beams as well. So we also have a design tab here, design and then design options and we can able to design. So what we are doing from here only we also have here design now. So it is not going to like make it pass by itself. So we need to do in a STAAD Pro and we need to come back. So there is no other options over here. export group for detailing, group table, design, so briefs everything. So tables, so what table you want? This is like a, if you want, you can able to just go for and click OK. The table it will come here. Otherwise, you can able to click here and you can able to see the particular table. So like this, we can able to make use of this RC Designer platform. So which is like a plugin to our existing STAAD Pro.